Okay, so today's topic, that is resolution of vector. Okay, before that we have discussed about what is the real purpose of vector. See, vector is used to describe motion in two-dimensional and three-dimensional, that is in a plane and in a space. Okay, but in one-dimensional, the direction aspect of any of the physical quantity, that is velocity, acceleration, displacement, any of the quantity, force, is taken care by the plus and minus sign. Now what about in case of plane? The direction aspect is being taken care by the vector. Now we are on the topic, that is the resolution of a vector. See, we already know that two independent vector make a one resultant vector. Two independent vector make one resultant vector. Can I get in reverse order the same thing? If I resolve a single resultant vector, if I resolve this single resultant vector, can I get the two component vector which has contributed to form this resultant vector? Yes, that thing we are going to learn in resolution of vector, that how we are going to get this component of the vector which is forming this resultant vector. Before that, we have to look for the important topic, that is unit vector. See, unit vector are playing very important role because they have the magnitude of only one unit, but they are very helpful in taking care of the direction aspect. If we multiply unit vector with any of the scalar quantity, that scalar quantity will transform into the vector, and that scalar quantity will now be having a direction. Okay, unit vector are three types. Unit vector are of three types, that is I, J and K. I vector is a unit vector with a magnitude 1, J is same and K is also with the magnitude of 1. Okay, but I, J, K are having different direction. For I, it will be x-axis, for J, it will be y-axis, and for K, it will be z-axis. Okay, so we will be using this unit vector to give the direction of this scalar quantity which we are getting during the resolution of vector. Okay, suppose I am taking any random vector, that is a vector. If I draw a parallel line, to the x, if I draw another parallel line to the y, okay, the length I will be getting on the x and the length I will be getting on the y. Okay, they will be representing the component of a vector on x and y. Okay, so when we draw a line on the x-axis, this line will cut some of the length of x-axis. This length is nothing but a magnitude part of one of the component of a vector. Let name this magnitude part as a1, and the length along y-axis will be represented by A1 and A2. Now, if we use parallelogram law of vector addition on A1 vector and A2 vector, we will be getting resultant as A. Okay, there must be some formula of A1 and A2. So for that, I will be drawing an angle theta, which is the angle between resultant vector and A1 vector. But before that, can I represent A vector as, okay. Now students, you have already learned that the opposite of the angle is represented by a sin theta, and the angle, that is the base part of the angle, is represented by a cos theta. So in place of a1, I will be writing as a cos theta. In place of a2, I will be writing as a sin theta. But one thing, here a cos theta and a sin theta are representing magnitude part, but what about the direction? So here comes the unit vector. If I multiply a cos theta with I vector, if I multiply a sin theta with j vector, then now a cos theta and a sin theta are converted into the vector. Okay, this is how we resolve any vector into two components of it. Okay, now tomorrow we will be discussing more about resolution of vector. Okay, thank you very much for watching this.